All right. So, this slideshow, as you probably already read from the title, is a brief rundown on a whole bunch of tips and tricks to help improve your robot game and robot reliability throughout the match. My name is Thomas, and he's Matthew.
Like Thomas said, we're Thomas and Matthew. We're both drivers for the Gearheads, as well as we've been on the mechanical team since what, 5 years now, 6 years now. So we've played in a lot of robot matches, to say the least. This is just a structure of what we'll go through today. So first we'll go through like basic design of a robot. And that's before games even start or before you're even at the competition. Second, we'll go over is just some construction tips to make sure that you're building a sturdy robot. Three, we'll go over wiring, as it's one of the areas of concern with a lot of younger teams is consistency through their wiring. And if it's not done well, it can cause a lot of problems for your team in the match. Four, we'll go over robot health and best practices, which will help your team keep your robot clean, as well as keep your technology working throughout your time in FTC. And then we'll wrap up with any questions that anyone may have.
All right. So for slide number one, that's our robot architecture and design, and these are some tips to help you improve the design of your robot, make it more structurally sound and stable. So first of all, you should be using a lot of right angles, triangles, and other strong shapes in your robot when you're building it for a robust frame for your competitions. You should also try and not use servos to support uh, like larger structures and arms, and you should support the servos with the structure of your robot. There's an image of that. Also, you should have a lot of metal in your robot for any piece that's going to contain a large load to it. So anything that you're connecting a large plate to, servos, motors, an arm, or any extender, that should be connected to metal at all times, and that'll help reduce your robot wobbling and keep it more consistent. And try to keep, especially your wiring and other vital parts of the robot, like your control hubs, covered so that they aren't damaged in competition.
The next thing we'll talk about is what we call the Rev Hub sandwich. There's a photo of it to the right. So there's an inner side plate on the robot, which is up and to the left of the Rev Hub. Then the Rev Hub is mounted to that plate with the four mounting screws on it. I believe they're M3 holes. And then on top of that, there's standoffs holding a plastic shield over the Rev Hub. And what this does is two things. One, it keeps your Rev Hub in a place that's not in the way of moving parts, and it keeps it safe during games. It also allows you to tuck a lot of wiring between the two plates. So instead of having wires dangle all over the robot, you have it all right there, which is just fine because nothing is moving in that part of the robot. The next big design thing is to design a battery holder. There's a CAD model of a really simple one there. It can also get as simple as just a rectangle with the top cut off of it for you to put your battery in. And what it does is it allows you to have a secure place for your battery. So it's not just taped onto the side plate or shaking around throughout a match. And this obviously helps with game consistency and keeping your battery's health good.
All right. The second thing we'll be going over is some good robot construction practices. So what you'll always want to do is put a ton of bolts on your robot, and that'll greatly improve the robustness. What we see a lot of the time is that, let's say that you have a bracket that you're connecting to a different one, and you put only two screws in it, or it's even one, that would be terrible. But if you do only two screws, that'll reduce the strength of everything, and it'll make things not align as well. And it's generally just a bad practice to do so. In addition to this, whenever you're fastening things, you should always try and use nylock nuts or self-locking washers wherever possible. And also, you can use a Loctite if it's not possible to put a nylock washer at somewhere or where it's critical. This will also ensure that screws over many matches don't vibrate out and that your robot doesn't loosen over time. Uh, Also, if you're building side plates or if you just want to connect plates together, uh, you'll want to use a whole bunch of standoffs, probably at least 3 or 4, and you want to use bolts that thread deep into the standoffs as well to improve the strength. And finally, you'll also want your rev hubs and battery holder for sure fastened against something really rigid and solid, and that because those are vital parts of the robot, and obviously you don't want them to be bumped into or tampered with or shaking around.
The next thing we'll get into is wiring. First we'll go through a bad example and a good example. So a bad example is a photo on the top left there you see. This robot, the bad part about it is that the wires are kind of all just entangled in a nest on top of the robot, compared to the good example on the right, where instead of having little individual wires that go to their designated locations, all the little wires come together to almost form, you can think of it as one big wire chunk, which is much easier to keep safe than hundreds of little wires throughout your robot. Um, Throughout the process of wiring a robot, which does take time, and you should take the time to do it really well because it can help you be consistent in games and you'll avoid a lot of issues of random disconnects throughout matches. You'll want to use zip ties, cable clamps, and it's called split sleeve. So zip ties are really good for holding all the little wires together in one big bundle. Cable clamps are really good at taking those little bundles and keeping them fastened to the frame of the robot so that they can't move throughout a game. Or if they are going to move, like they're on an arm, the movement is predictable and repeatable every single time so that you know that it's safe. And then split sleeve is really good for things where there's wires really close to moving parts. What it does is it ensures that the wires don't get it caught into moving parts and they keep it all in one bundle, like we talked about. Like I said, bring all little wires together and then bring that big bundle into the rev hub sandwich, like the photo showed earlier. And the final wiring tip is to use the rev grounding strap and bolt that to the robot frame or a robot side plate, something solid and metal. And this can help you avoid a lot of disconnects or ESD issues in the future.
All right. On number 4 is your robot health and good practices when handling the robot. So this will improve the longevity of a lot of parts for your robot because there's a lot of sensitive instruments like servos, and you don't want any dust getting into your robot over time. And this will just help make your robot more consistent over time. So firstly, you'll want to always keep anything that you're transporting the robot in or practicing on, like your practice fields, clean. You can just sweep them up every once in a while, and it's a good practice to not step on them with shoes and take your shoes off. That'll lower the amount of dust on the field because over time that will get into your robot and it will ruin your parts. You'll also want to keep your driver hub and your robot inside most of the time and kind of in a room temperature environment like this, especially in the winter weather like Wisconsin, because if you let them get into the cold, it'll degrade the batteries and it's just really harsh on a whole bunch of the components of the robot. In your matches and even when you're practicing, you'll also want to use a new robot every single time. This will improve your robot consistency and your performance, and it's just a great thing to do because it makes your team better and it also is healthy for the robot and the batteries. You'll also want to bring plenty of spares. Probably, if you're practicing, you'll want to have 4 or 5 batteries all charging at the same time. Also, this goes for the rev hub mostly, but you'll want that charging constantly. Uh, it will die very quickly, especially if it's brought into the cold. And when it dies, there's a whole bunch of technical issues that come alongside that. We experience those every so often, so we even have a battery bank that's attached to it at all times. Also, for transporting your robot and your controllers, you'll want to consider making a robot case. We have a box, and there's a couple field tiles in the base of it that prevent the robot from hitting any of the surfaces too hard. And we also have a control board that has Velcro that attaches to our controllers, so those don't go flying everywhere. when we're moving them around, and it prevents them from being damaged. And also, as a best practice in your qualifier, to assign a lot of the roles in the qualifier, so and to give people their task and a checklist for the robot so that people know what to do, they know when to change the batteries, and if there's any parts that need to be changed, and that'll help improve your competition.
Yeah. If you have any questions, now would be a great time to ask them. Another thing that sometimes comes up is after watching over the videos or reviewing the slides, you have questions after. So feel free to email Coach Newstead there at that email, and he'll get back to you with any updates he can for you. Also, if your team has a CAD model or custom parts that they want made, we're part of the First Wisconsin Production Hub. And it's a great program that us, as well as many other teams, can make parts for your team for often free, and if not free, very low cost. And that's a great way for your team to get into machine fabricated parts on your robot. So, does anyone have any questions about anything we just went over?
Would you guys be able to talk about the planning process that you go through when you start out the season and as you plan your robot out?
Sure. So, what we often do is we plan in, so first we plan for capabilities. So we do what's called a game points matrix. And what this does is it measures tasks on the field. So for this year, say it's scoring in the high bucket, scoring in the low bucket, and then hanging specimens either on that high bar or the low bar. And we'll put points next to each task, as well as a difficulty. And what you want your robot designed to aim at is to do things that are high points and low difficulty. And over time, your robots will get better, and you'll just start aiming for things with more points. From the game points matrix, you can make a list of capabilities. So for this year, if you wanted to be able to score in the highest bucket, you'd say, we need an arm that can extend up to X feet tall. I'm not sure what the number is. And then from there, from your list of capabilities, you can design subsystems is how we think of it. So we design our drivetrain separately. We'll design the arm system separately, the intake system separately, and then bring those together.
So that process separation, Nate, has been important for us. And just as Matthew mentioned, step one is to brainstorm what capabilities you want your robot to have, what functions or tasks it can do, and then rate those on, is it an easy task to do or a difficult task to do? And does it score a small amount of points or a high amount of points? So then you can build this chart, which on these two separate axes rates, is it easy or difficult? And does it score a lot of points or not score a lot of points? And then you focus your robot brainstorming and what you want your subsystems to do, just as Matthew said, on the things that are easier to do and the things that score more points. And then, use that as a tool to kind of focus your brainstorming and build out these subsystems and start to prototype the subsystems. I think that's a really good process too, is to, if you've got, as an example, if you've got 2 or 3 different ideas for a claw, you can build those claws without the robot. We did that this year. I think we built 3 claws offline early in the beginning of the season just to test basic concepts. And so that prototyping of individual subsystems can be really important. And it helps the team go off and focus. You can divide the team up and have them work on multiple areas at the same time rather than everybody kind of crashing into each other at the beginning of the season. So that brainstorming capabilities and ranking how important they are, then brainstorming subsystems, starting to prototype and test those subsystems, and then bring it all together as a robot. That overall is the basic design process.
And do you guys use computer software for that at all? And
Well,
if you do you have recommendations of software?
yeah, so we'll often whiteboard first for ideas and then do basic prototypes. And from there, we'll do a final CAD model or an initial CAD model. Right now we use Onshape, which is a web browser one. This is good for certain things, which is it's easy to share files amongst the team and almost work on things in sync if necessary. It's also accessible for everyone since it's a web browser, so you don't need a big fancy computer to run a program like a Fusion 360. And it's also a lot easier to learn, I think, than a Fusion or an Inventor. Yeah.
Also, with Onshape, it's also very easy to go. Many of the sites also support it too. So if you go onto, well, if you're using any software really, you can go onto a website, and if there's a common part that you're going to use in your claw design or in your prototype design that you know you're going to use, you can import that from whatever that website is into your CAD file, and then you can use that inside of it, and it allows you to get a more exact picture of what you're building.
So example, if you're using Go Builder parts, you can download the CAD files from the Go Builder website, bring those right into Onshape, and then basically, all you're doing is assembling the parts versus drawing lots of things on it. So that can be super helpful too.
Thank you.
For sure.
Okay. Any other questions, Nate?
No, thank you
Okay, good.
very much.
We're really, and I'll say it for as we distribute this recording too. The team has invested a lot in the First Wisconsin Production Hub, and again, just as Matthew mentioned, if you have a part that you want 3D printed, if you have a part that's made out of metal that you need fabricated, have a plastic plate, you want to put a side plate on your robot, but you're not sure how to fabricate that. Reach out to the Wisconsin Production Hub. Gearheads are on there. We're super happy to be making parts for teams. And the intention of that is to provide teams with a resource where they can go to quickly get parts and not have to pay a bunch of money for online services for them. So if you need a part from a 3D print to a machined piece of aluminum, let us know, and we'll get you hooked up with that program and be glad to help.
Yeah, I actually do have another question then. You guys have obviously, as you said, been doing this for a while. Do you find that you use standard parts or that you fabricate a lot of your parts after having experience of doing it for years?
Yeah.
Yeah.
Yeah,
Go ahead, Matthew.
I think as we've gotten, obviously our first few years, we used a lot of standard parts. But more recently, I think the robot this year has two standard frame parts. So it's pretty much all custom parts. And a big advantage of that is you can make robots that are really small, and a lot lighter. The Rev or the Go Build a kit parts, often you don't have a lot of degrees of freedom with angles you can make. Like you're often stuck to right or 45-degree angles. And you also don't have a lot of freedom with space usage. Robots often end up big and clunky instead of small and really quick, like custom part robots can get you. So it's a
That's a
process that
journey.
you definitely can't.
Yeah, but I wouldn't be intimidated by that. It's a journey, right? I mean, we started out the first couple of years, it was all off-the-shelf parts, and you can build fantastic competitive robots with that. So, especially, I mean, we like the Go Build a system a lot. I think that's quite well done. Lots of options. But as you go on and you start to step into, I need a side plate, or I want to 3D print a battery holder, or I have an idea for a claw that's 3D printed, or some simple metal parts. We just walked into it like that, where more and more parts of the robot started to be, custom CAD designs, and then the team was super interested in learning the fabrication processes. And we started out with manual processes, and we've kind of stepped into CNC. If you look at the Gearheads web channel, the Gearheads YouTube channel, you can see there's a quick series of introduction to fabrication videos, just how do you make metal parts with hand tools. And those are some good resources too. But I guess my message is I wouldn't be intimidated by it. It's a bit of a journey. Start with standard parts, and then as you feel the need to say, hey, I want to do something that's not in the catalog, you start to figure things out from there.
Thank you very much.
For sure.
Okay.
Okay, that we'll wrap up there. Send out the video tomorrow morning, and get on to next week. I think webinar next Thursday, we're going to talk a little bit about the roles of a team at a qualifier, all the things that are going on at a qualifier, what you should have people focused on doing, from the drive team to managing the pit to scouting, etc., and give you a little bit of a template to say, hey, this is how you can organize as a team during a qualifier. All right, very good. Have a good night. Take care.